Good afternoon, everybody, and welcome to our session. Hope you are still fresh. It's a little late in the day, but we want to talk about breaking free from cloud banking on self-hosted Kubernetes. First up, about me, I'm Hedegaard Christiansen. I live in Copenhagen, love to travel the world. I joined Saxo around 6 years ago, and now serve as the head of container platform engineering. And besides that, I'm also the chairman of Cloud Native Denmark, that's organizing the two previous KCD Denmark, and now we changed the name to Cloud Native Denmark, and we will have a conference later this year. One of the things we do for our conference is that we donate the profit to charity to foster young talents into IT.
Yeah, my name is Kārlis Akots Gribulis. I also joined Saxo Bank only last year, but I've built Kubernetes clusters before for companies such as Velux and Accenture. Spoiler, I'm a Kubestronaut and on the way to Golden Kubestronaut. At this point, I'm a bit unsure if there's 14 or 17 certificates now, based off yesterday's announcement. Yeah, we'll have to see how far I am. And I'm not from Denmark, but I reside in Denmark currently, so I'm from Riga, Latvia.
Yes, about Saxo Bank, we are an online trading platform. We are founded in '92, so compared to other banks, we are pretty young. We have 100 USD billions in client asset, 1.2 million customers, a lot of financial instruments that you can trade, bonds, stocks, CFDs, and whatnot. And we are too big to fail, as it states there.
Yeah, so a couple of disclaimers before we continue, as some have said title might have been a bit too catchy or maybe misleading. So to clear some things out, most of the core banking itself is not run on Kubernetes. It's not even on Linux. It's on the good old Windows machines. But it's not like we don't have any critical workloads. There's a lot of critical components still running on Kubernetes. So if those suddenly disappeared, clients would notice and it would not be good for the bank. One more important thing, this is not an advertisement for or against public cloud, private cloud, whatnot. Look at it as our experience, our story, our case study, and whatnot. And the migration is not fully finished, but we are in the middle of migrating our most critical components at this point in time.
Yes, so what was the initial motivation to begin this journey? First of all, we are a bank. Compliance is a big thing. And for that, we need to have an exit plan for exiting public cloud if we need to. We also need to, we experience some of the running 4 years in public cloud now. We have actually seen some reliability issues. It's not always good. There's some limitation, even in the cloud. But the biggest kicker is the cost, and that's also the title of it. That moved things along and kick-started things faster.
Yeah, a few more things we gain. We will give more insight to the previous points and these ones. But just to highlight some extra benefits we got is cluster creation speed, which we basically increased by roughly 15 or 20 times. And then obviously security benchmark improvements, which is, as a bank, it makes sense to improve those numbers in general.
So the biggest one here, and if you read the abstract, you kind of have the answer to it. We approximately save 85% by moving our stuff to on-prem. And this is the cost for compute and storage. We took all the costs we could figure out from running our own data center, the manpower, network, cooling, power, everything. And we took it into a 5-year period and compared to what we pay for what we are running in public cloud. That's 85% saving. One example I want to give you. You can buy one server for 20,000 euro, write it off over 5 years, that's 333 euro a month. That one computer gives you 32 physical cores, 1.5 terabyte of RAM. You can run a lot of workload on that one. And I would encourage you to look up the same amount of power for a public cloud VM.
Yeah, so the next benefit is cluster creation speed. I'll leave the video in the background. That's basically how fast we can make a cluster in our on-premises setup. And below you can see a picture of how it is in our current managed clusters. And you will see the difference and why it's a good benefit. So I'll just focus on the below picture, as you can see, the deployments might take roughly 30 minutes. This is just a basic cluster. It's not GitOps, it's not applications, nothing, just a basic cluster with the nodes in it. And 30 minutes, it doesn't impact you actually day to day in your production clusters, sure, but we have multiple short-lived clusters that have to be rebuilt every day. And let's say we have 20 of them, and a team wants to deploy them one by one. Then that's a big chunk of the day that just gets lost because of that. So because of that, we relied on something that our cloud provider supported, which is stop and start feature of clusters, which basically allowed you to stop the cluster, meaning all the virtual machines scaled down to 0, state was stored in etcd, you save money, basically win-win, and then the cluster start is 2 or 3 times faster. So it should technically be good, but the problem is the stop and start feature is reliably unreliable from what we've seen, because the state does not always actually match the reality. And we've had few cases where the team that is deploying the clusters, they see, oh, hey, our cluster is broken, please fix. And then we're like, okay, let's see, what's the situation? We see that there's maybe no pods running or they're pending and whatnot, and then we could see that the webhooks, like the ones from Kyverno or Linkerd, are blocking the pods. So we're like trying to figure out, okay, what's up, why is that? And that's because nothing answers those calls, and that's because in this case, Linkerd pods are not there because it's being blocked by the Linkerd webhooks. So there's a bit of a loop there, which sometimes happen. It's also not very stable. So we've had this situation where the policy blocks itself because the workload is not even there. So that messes up and wastes a lot of manpower as well. And then we had a weird case of ghost pods because of this state mismatch as well. We've had situations as well where we see the pod is running, it's healthy, the service is there, all good, but the website or whatever is behind it is not answering, and we're trying to figure out, okay, what's up? And then you see the pod is marked as running, but the node it is marked as running on does not exist because the node has been removed on the stop part. So we had few pods that, or the API server thinks it is there because it's stored in etcd that it's actually there, but it was not properly cleaned up. So, and the controller and the scheduler doesn't actually bring a new pair up because it's technically there, but in reality it's not. It's an illusion and a ghost, as we called it. So we needed to build some custom solutions as the Ghostbusters. We built basically a cron job that runs every 5 minutes called like Ghost Pod Destroyer or something. So it just checks all the pods and see if there's a node that's not there and just delete it. And then we introduced one more node termination handler, which basically would help to prevent these situations as well, because these also happen on other types of node that can suddenly disappear.
Yeah, spot nodes.
Spot nodes, yes, yeah. Exactly. Yeah, and then on the extra features that happen is the security benchmarks and transparency, which for me as a developer is great and awesome because I like to change and see things, how they actually work, because in cloud they're often abstracted away or not visible at all. So the extra visibility helps, and it can be seen more in hand with these CIS benchmark improvements. So this is what we increased it in like 2 or 3 weeks, basically almost doubled it in our on-premises, because in cloud providers, at least in ours, you cannot change anything in control plane, and maybe your CIS benchmark tool still reports those issues, but you cannot do anything, and now we can. And the remaining percentages are basically, if you're familiar with CIS benchmarks, those are the 5-something rules that are mostly about accesses, maybe some container specifications and so on. So those are things we still have to iron out, but the major part of the actual control plane we could fix and change. One of those things is etcd encryption, which obviously everyone should have and is a good thing. And you might think, as we thought, that maybe it's by default in your cloud provider. Please check, because for us, it was not enabled by default, and enabling it is also a bit tricky, and some features were only in a preview mode, which also does not bring confidence. They relied on, obviously, their own disk encryptions inside the data centers, which we also have. So on top of that, we at least could do etcd encryption and be more compliant. One more feature that might not sound something spectacular is we had control over service account certificates. I'll explain a bit later on why it's actually important and why it played a big role for us.
So one of the things is that when you move on-prem, there's the lack of external support, depending on the solution you choose, of course. But one of the questions that has been asked is this: what if the cloud provider can't help it? What do you do? We actually, after I've been running for 4 years in public cloud, we actually do a lot of the things ourselves. It's rarely that we reach out to the provider itself. Even if there's something very critical wrong, we do most of our stuff ourselves. So that has given the confidence that we can actually do this, and we have the competence to actually do it. So initially, maybe some of you in the crowd from Mercedes, I want to talk to you after, but it was actually an idea coined in Valencia 2022 at KubeCon, where there was a keynote from Mercedes-Benz about running over 1,000 clusters with Cluster API. With Cluster API. So that was the first idea that was born there. And that's also what we're using to do this on-premise installation. This is actually a picture of the first POC cluster from our own data center. So we decided to go with some servers and then a storage system. And the thing was that, should we go with storage inside as an vSAN or a CI as a hyperconverge? But the thing is that we don't know the growth of the different parameters, meaning that how much compute do we need, how much storage do we need. So in order to kind of grow with the load coming in, it's much better to have that flexibility that we just can put more hard drives into the SAN, and we get more storage and put more hosts on when we need more compute capacity. So that's what we went with. Another added benefit to that is that it can roam around the VMs, and infrastructure can do the maintenance without reaching out to us. Another thing is that we already have a platform running in the public cloud, where we use GitOps to bootstrap it. And the only things we are only changing is the things in the top you are seeing. So we, instead of the public cloud, we use now VMware. I know there could be some discussion about that, but it's a good fit for our organization. We use Kaby, and we use the CSI driver. There's many of the things we have been changing in order to do our on-premise move, and then we use the rest. So here's an overview over what are the different components that we switch. So we use Dex for the single sign-on. We use Harbor, HashiCorp, and Minayo. I will let you pick that one up, Candice. Rook came in because one of the things, I will get back to that, why we choose that, core DNS for the DNS. This about persistent volumes, we have an extra thing to consider there because of our data center setup. I will come back to that.
Yeah, and we know how it goes with the plans, not according to the plans. So we still needed to change a couple of things. One of the things is we needed to replace Minayo with Rook. You might ask why. Some of you might know this year DORA kicked in high and strong. So we needed to really look at our licenses. And the AGPL free license, which comes with the open source Minayo, was a killer for us because of the hard copyleft approach. So we wanted to avoid that for some liability reasons, and enterprise Minayo was out of the question due to costs. So we went with Rook because it still supports the S3, which we needed. So it fit pretty well, and we already used it for read-write Mary storage, as Per already mentioned. And to manage Rook and Minayo before, initially we made our own operator around Minayo to manage users, buckets, policies, and whatnot. Then we found some issues, and maybe to make it easier to maintain, we used a cross-plane provider. There's one available. It was slightly dead, to be honest. They didn't reply to my PRs for like 4 or 5 months, so we forked it and extended it how we wanted. But yeah, now for Rook we needed to redo it again. So we made there is also technically a safe provider for Rook via crossplane, but the problem with it doesn't work with private registries, so we cannot really use it. So we just made our own provider from scratch, in a sense, again. One of the things we also had to change, as I highlighted before, is the service account certificates. This is where it comes into play. We use workload identity in our workloads to communicate with external resources like vaults, databases, Kafka, and so on. And it has a thing called managed identity, which in our architecture setup, it was one per environment, and it would be shared across the clusters in that environment. And it comes with a problem because it can only have 20 attached federated credentials, meaning only 20 clusters could use it, which usually would be fine. But in our test environments, as I mentioned, we have dynamic test clusters, and they can easily go above 20. And we needed then to fight for the slots or maybe make some custom solutions around it. But in on-premises, we don't have this issue, as we can generate and reuse the same certificate in the, for example, for our dev clusters, test clusters, and so on. And what this means in the workload identity, we can then use only one credential for the whole dev and the whole test separately. So we will not face this limit anytime soon or ever, hopefully. Yeah, one more thing that we have to consider, which Per will talk a bit more about, is we would need to spread the control plane across data centers, which is something cloud providers do, but we needed to figure out how we do it and how we spread it out nicely, because we have 3 data centers. In all of 3, there will be control plane on, but only on 2 actual application workloads will be running on. And then the last thing might be slightly controversial to some. We've had different talks with people, is we replaced HashiCorp with sealed secrets. Obviously, as you some might know, this means we only replaced for the secret management part. There are still use cases for maybe key management, and we had some applications where they have auto-generated secrets, which was supposed to automatically go to a vault, and then developers never see it. So sealed secrets there doesn't fit. But for all the other cases, we replace it with sealed secret. There were a few reasons for that. HashiCorp itself, it's good, but we wanted to store the vault itself inside the cluster. And it's not super friendly for in a GitOps world, because you needed to manually go in and seal and unseal the vault, which is not great, and we don't want to use any manual steps. There are some other tools like bank vaults that technically does it for you, but it's also slightly outdated and doesn't follow or has fallen off the cadence of HashiCorp Vault. And the third, but not least, also is, again, costs, to reduce the cost as much as we can. Yeah, and then for the migration, we didn't want to wait for 5 years until everything is done and perfect and then move people. We wanted to move them as fast as I can, due to also saving the cost as much as we can. So there were some downsides we accepted and be like, okay, sure, we'll deal with it once we, move everything, and then we'll clean it up later. One of them is the workload identity. As I mentioned, we'll still use it because there are still maybe some vaults or databases and Kafka and so on that they might still have. So we still have a reliance on our public cloud for that part. And as I highlighted before, is for some workloads that have key management, they still use key vaults inside the public cloud. And then also if they have this automation, or if the developers are just so extremely stubborn that we're like, okay, sure, we'll deal with you maybe in a half a year, then we'll bring you over. And as I mentioned slightly before, we have different availability zones in our data centers. Well, we have 3 of them. We use them all 3 actively only in our pre-production and production environments, which means that in our dev and test, it's all hosted in one. Well, that might not be an issue. For the initial migration, it does bring some bumps, mostly because we have Helm charts that already use topology spread constraints for zones. And how do you spread if you don't even have that label, because you have only one data center, one zone? So our quick solution was we kind of faked it, and we just added labels for some nodes, so it could actually spread, even though it's not a real zone in that case. Yeah, and then for the workload migration, it is going on. Don't tell Per, I actually stole this from our official sheet. This is the official, our waves, how we split it out. So the terminology, especially the last one, is real. It's not something I just made up. It's split in multiple parts, and as I mentioned before, we are in the middle of moving our critical pieces, as we also call them, the big spenders, so they make extra reasons to move them. And the migration itself, aside from the components we needed to change that we highlighted before, it's actually pretty smooth. There's not been many hiccups due to Kubernetes itself and GitOps, because Kubernetes, it's, yeah, as they mentioned in the keynotes as well, it just works. It's awesome, amazing. And with GitOps, you just point it to a different cluster, it also works. And in our current setup, we have, to make developers change as few things as possible, we also have config maps in each namespace with some variables or environment variables that they could use, which, for example, points to ingress URL or where Kafka is located and so on. So they don't have to even worry about it, and they could just reuse basically move to on-prem and change as few things as possible. Per even had some presentation where he wanted to show how to move things to on-prem, and he forgot to change our settings from public cloud to on-prem, and the demo still worked because it mostly used the environment variables from our config map. Yeah,
yes. So one of the things that Kārlis mentioned was that we need to have high availability for our production setup, and that imposes some challenges in how do you route the traffic from the kind of outside and in. We have multiple data centers, and that was a big challenge. I will not say we have completely solved it yet, and it's not that there's not solution for it, it's more like how do we make our legacy kind of network conform with all this and make it a Kubernetes way so it's automated and people can do it the Kubernetes way. That we still need to iron out small things out. Also the fact that the different data centers we have, they don't share the same subnet. They also impose some challenge when you have IPs and whatnot. And if you're used to being a public cloud, you kind of have one IP for your, let's say, your ingress, and it can float kind of around the different zones. We cannot do this here, so that's different challenge in that. Yeah, comfort with our on-prem network.
Yeah, and one challenge we also have, or we're a bit on the edge about it, but this is a rough picture how we have our cluster set up. We use Cluster API for managing them, and yeah, we have it basically all starts from a kind cluster, either be it local or from a pipeline, which will create our registry cluster, as we call it, our grandmother cluster, because that's the one that actually makes the management cluster that would manage the cluster for our workloads. But the problem is that once that kind cluster is done, it will move the state and everything to the registry cluster, so it becomes self-managed. It works now, but it brings some potential issues that, hey, you know, it's one point of failure, and then maybe if something goes wrong, maybe the autoscaler plays a bad game with you and then goes haywire, or you misconfigure and the registry cluster it down and whatnot. So we'll still monitor how this is performing, because we might maybe go back on it and not have the registry cluster be self-managed, but be just a regular cluster that you make, for example, with kubeadm or something like that, and it would be solely just managing other clusters and not itself.
I think there was another talk yesterday about the chicken and egg problem in all this. So yeah, we need
from another Swiss bank. Yeah, so
yeah.
This is still a hot issue we need to figure out.
Yes. So the vision for the future, being agnostic, meaning that we will probably not go back to managed cluster in public cloud. We will use the cluster API to deploy Kubernetes on raw VMs in order to have the same setup anywhere. And another thing is to look into KubeVirt. I really see a lot of potentials in KubeVirt in order to kind of look at our legacy world, as Kārlis started out saying. We have a lot of things running on Windows. And I think there could be a lot of potential to see if we can leverage some of the same features we get, capabilities we get in Kubernetes, like DNS, certificates, and load balancing. All this is a hassle in the old world, I can tell you that. ARM CPU. If the hypervisor couldn't support it, I would really like to go there, but we are not there yet. And the main reason for that is there's more performance in it, and the cost is better. So when the hypervisor is there, I will gladly hop on to that.
Yeah, and then now that we're closing to the end, some people might ask, you know, after this, should everyone move? Is this the new way to go? No. It's not that simple, right? Everyone should consider it a bit more, because it really depends on the use case, and you really should evaluate yourself if this fits for you, because I think Saxo is one of the rare cases where it actually fits so perfectly, because as Per mentioned, we already had an existing team, already existing data centers, we already had the groundworks were already done. So it made things much, much easier, and the experience was there, so it was almost like plug and play. And then, you know, if you're like a very small company, like a startup with a couple of people, or don't have the experience, probably not worth it. Or if you're, as in quotes, truly global, it's a vague term. But if you would have, I don't know, have to serve 60 countries and be in like 80 data centers across them, and you don't have the sophisticated teams for everything to be in all places and manage it, it also becomes difficult. That's where cloud plays a good role. But in Saxo's case, we're not that global. Yeah, and then this wraps it up. Reach us to LinkedIn. Don't forget to rate us, and thank you all for being here.